Good morning, everyone, and thank you so much for joining us on another NDD webinar. We're just so excited that you have chosen to join with us. This is a new series for us, and we're really excited to get this series kicked off this morning. This is called Beyond the Boundaries, Exploring NDD's TrueFlow Technology. I'm so excited to be able to present to you an exciting interview featuring this beautiful creature that you see on your screen. So what makes NDD's technology unique? And that is our TrueFlow technology. If you've been on other trainings with us in the past, you know, we talk a lot about this and we brag a lot about it. So we really wanted to explore how it works and why that makes a difference. All right, so how does it work? The TrueFlow sensor. It uses an ultrasonic pulse transit time measurement, or that point-to-point ultrasound. So this is a simple and proven method to measure how long it takes for a sound signal to travel from one point to another. Using this technology, there's no moving parts, there's no manual calibration required, and there's no maintenance. So the contactless flow sensor, this is commonly used for liquid measurement or for liquid flow, but we have used it for airflow measurements in lung function diagnostics. So we kind of broke down exactly how this measures in the chart that you see below. So these two ultrasonic transducers are located diagonally across the gas path, most easily seen here on the EasyOn PC. As soon as the air passes through, the pulse of the ultrasound is emitted by one transducer and travels diagonally through the gas flow and is received by the opposite transducer. In the meantime, a second pulse of ultrasound is emitted from the opposite transducer, which travels diagonally against the gas flow and is received in the opposite transducer. If there's no airflow in the flow path, then the upstream and the downstream transmit time are identical. As air flows from left to right, the upstream pulse travels faster and the downstream path travels slower. It is the results that is the difference in these downstream transit times. So what are the operational benefits to that technical slide we just shared? We're using this to measure airflow measurements for lung function diagnostics. This allows us to be calibration free or manual calibration free. The original ultrasonic flow measurement is highly accurate in all flow ranges, regardless or independent of gas composition, environmental pressure, temperature, humidity. All of these things create a sensor that does not need to be manually calibrated during its lifetime. There's also no risk for cross-contamination. NDD's advanced lung function testing products were originally designed for effortless infection control. They're small portable devices with easy to wipe surfaces. There are no fragile sensor parts that need to be cleaned or removed between patients due to this TrueFlow technology. The testing elements do not touch or come in contact with the patient's actual breath. So we can use those single-use mouthpieces for an effortless exchange between patients. The sensor is never, again, in direct contact with that patient airflow, and so it really is a hygienic and resistance-free solution. Again, there are no moving parts, no codes to enter, no screens to catch rogue sputum, and no disposables to calibrate. The ultrasonic flow measurement is independent of all of those environmental factors that can cause issues in traditional pneumotachs and turbines. So what are some of the real life applications for this, for this technology? We know that it's very versatile across a wider range of application, spanning from pediatrics to adult patients. Today, we get to highlight some dolphins and cetaceans, sea mammals, and even in extreme environments like Mount Everest. Regardless of the settings, you can trust that you receive high quality data. Now, the disclaimer of this is, of course, our EasyOne products are medical devices, and they are intended and approved to be used in healthcare settings by clinicians. But some of these examples that we're talking about today have been for research purposes only. And getting on to the highlight of this webinar today is we are going beyond the boundaries with Dr. Andreas Fahlman. He is a comparative physiologist with the Oceanogràfic Foundation in Valencia, Spain, and they have been using NDD's TrueFlow technology to research pulmonary disease in dolphins and other cetaceans. You can kind of see the adapted technology in the picture here. And we're so excited to be able to share this interview with all of you. All right, thank you so much for joining us today, Dr. Fahlman. First question, tell us a little bit about yourself and about the work at the Oceanogràfic Foundation.
Thank you very much for inviting me. This is really nice, and we've been working a lot together for the last 10 years, so it's a nice way of actually doing this official. So my name is Andreas Fahlman. I'm a comparative physiologist. I grew up in Sweden, but I've then worked, mainly I work in the US. I work in the US and also in Spain. So I work at a foundation in Valencia, Spain, which is my sort of my hub where we do a lot of the work. The advantage with working there is we can use the animals in the park. So we can study the animals that are living in the park and that are basically guest meat. Because these animals are trained, we can then use them under controlled circumstances and do a lot of these work and these studies that we're doing. So I'm interested in understanding how these animals work in their environment. I sometimes call myself a car mechanic of animals. So I'm trying to look underneath the hood to see how do they function. And I'm particularly interested in how the heart and the lungs are functioning together. Initially, I was interested in cardiac physiology, and then I got interested in lung physiology, and then now I noticed they're actually a couple and they work together. So one is affecting the other. So every time you take a breath, it's affecting the heart rate and perfusion. So this is what we're looking at. And understanding climate change and how the climate is affecting these animals, we were interested in, especially in diving animals, in cetaceans and in seals, understanding how do the lungs work when these animals are diving underwater, because pressure is affecting gas-filled spaces. And we started working with cetaceans. The first work we did was we tried to do this in the wild with sperm whales. And sperm whales are quite big, and we paddled up to them in a kayak and tried to put our little spirometer over the blowhole, and we realized this is not going to work. We started then doing some work in various aquariums, and I contacted Christian Boos, who's working and is one of the founders of NDD. And this was a sort of a great segue. He gave us a lot of information, a lot of his expertise and knowledge in pulmonary physiology. And since then, we've been interested in using the NDD technology, so this TrueFlow sensors and the ultrasonic technology for use in these animals, and to basically to improve how we do things, to get better measurements. Especially one of the things that are especially in the field is having a unit that doesn't need to be calibrated all that often is great to have. So this is sort of our background and where I worked up until now.
Yeah, excellent. And you kind of touched on a little bit of this, but the next question is, what inspired your team to focus on cetaceans, dolphins, and their pulmonary health?
Yeah, so thinking about what these animals do every day out of their lives, they dive to great depths, they're exposed to high pressures, which basically cause the alveoli to collapse and then be recruited. And this is a huge clinical issue for humans. So the understanding of how do these animals cope with this, how do they deal with this physiology and what is different in their physiology was really interesting. And sort of we started off thinking, what is different in these animals, and can we measure the physiology to one, understanding physiology under unusual circumstances for humans, but also understanding what are some of the limits to these animals and how they're doing things.
Right. And could you provide some information for us on how dolphins actually breathe, their lung function, their respiratory system? What is so different about dolphins?
So dolphins, like humans, are mammals, but the lungs look very different. So in humans, you have these lobulated lungs. You have two lung halves, and then you have lobulations on the lungs. In cetaceans, there's a right and a left lobe, and that's it. But they also have what's called, I think they call it in humans a pig bronchi. So they have this accessory bronchi on one side, which is an unusual feature. And you see that a lot of Artiodactyls, pigs, for example, have it. And this is in humans and in some mammals, this is a pathology if you have this anatomy. The lungs are very, very different in how they function. They have a lot of what's called collateral ventilation. So basically, if you have a collapsed region of the lung, gas can move within the lung itself through these pores. Some of these are called pores of Kohn. So you can have basically the entire lung is one system. So gas doesn't need to go through the conducting airways to fill one portion to the other. And this we think is beneficial for them and one of the adaptations that they have for diving. And especially in cetaceans and the toothed whales, the dolphins, pilot whales, sperm whales, they have very high respiratory flow. So the exhales can be of really high flow rates. So we measured flow rates up to about 160 liters a second, which is about 10 times as high as a human. And they have, because of how the lungs and the chest is constructed, they can empty almost the entire lung during a breath. So their vital capacity is almost equal to the total lung capacity.
Oh, wow.
Which is something that has been misunderstood until we started doing all these measurements, because
Yeah.
then people have been thinking, oh, they can do it, so they always do it. But that's sort of saying like, well, you can run a marathon and therefore you always do it, which is
Right.
not true. And so we've done measurements on a lot of different species, and we noticed that usually what they do is they use about 30 to 40% of their vital capacity. Each tidal volume is a fairly big portion, about double from that you see in humans especially, but also in other land mammals. So their tidal volume is much greater. And then their respiratory frequency is much lower. So they breathe only once or twice a minute in the dolphin, for example, up to three breaths a minute. So they breathe very differently. And then they have different scope for changing breathing when they're doing things like breath hold diving or when they're exercising. In wild animals, and this is something where NDD has been really crucial lately, there is a high prevalence of respiratory disease. And we've been working with NDD to try to come up with a portable system that we can then supply to these networks, these stranding networks that go out and help animals on the beach. Because if you have, let's say, 3 animals on the beach, you want to know which are the best candidates to be put back into the ocean. Because if you have limited amount of time and limited resources, then you want to focus on the animals with the highest chances of survival. And therefore, being able to diagnose them with respiratory disease can be important to triage these animals to help the ones that have the highest chance of surviving. So we've been working with NDD to develop this new spirometer.
Yeah, absolutely. And I guess that leads right into the next question. Can you explain how you're using our technology from NDD to test the lung function in these dolphins? You mentioned earlier about much higher flow rates, much higher volume. So how are you adapting this technology to be used in dolphins?
Yeah, so we discussed this through several years, and finally I gave in and listened to some great advice from from Christian in suggesting what we should do is we should combine several of these flow heads that NDD has, so these TrueFlow sensors. So with help from engineers from GNO Embedded Systems and from NDD, we then have built a system that splits the flow. So the animal is breathing into this. It splits the flow into equal parts. And then each flow sensor can then take a portion of the flow rate. So we split it into 12 different TrueFlow sensors in a rosette. So we're then having to combine that electronics inside the system and then giving an output. So this was one way of doing it rather than to building a completely developing new technology. So doing this in a way that we could use existing technology, and the D has done a lot of development on this system. So if we could use all that knowledge, then we didn't have to start from scratch, but we could use some of this existing knowledge. And then last year in April 2024, we did the first tests with this portable wireless system, which worked really nice and well. And then we've been using that in the field and in various aquariums since then. So.
Yeah, that's great. And has this adapted technology presented any unique challenges in measuring the lung functions in dolphins?
Yeah, we're trying to do the best. I want everything, but then we sort of need to adapt it to what is the question. Are we doing this for diagnostics? Are we doing this in a controlled environment? Are we doing this in the field? And that sort of sets some limitations. If we're doing this for research, there are some adaptations we do. For example, the stem of the spirometer can be made longer so we can get better flow dynamics in the system. For animals on the beach, for example, stranded animals, they usually don't breathe as hard and as powerful as animals that are, one, in water and two, are healthy and not in a stressful situation. So we can make some adjustments to this depending on if we have lots of time and we're in an environment where we can take our time, or where you're on the beach and you really need to the health of the animal is always the priority, but you need to get these animals back into the water as quickly as possible. So therefore, we need to make some adjustments. But it's been working really well. The system, the software, it's very simple to teach someone to use this system. This has been one of the key things, I think. A lot of this technology is, a veterinarian goes through schooling for several years, and then they learn how to do different procedures. They learn how, through time, gain the experience of drawing blood, do an ultrasound. And here I can give a piece of equipment to an untrained person, teach them in the parking lot. In 5 minutes, they know how to do this. Yes, it's difficult to assess it, but with time, we can then, here's the output, and we can get an objective index of this is the health of the lungs of this individual.
Right. And you had mentioned the calibration factor earlier with the ultrasound sensor, but are there other specific features to NDD's TrueFlow technology that were particularly valuable to you in this research?
I hope that people will take the advantage of this, because I think with this technology and with what NDD has provided, I think there's some things we can start to change how we're doing things. It takes a lot of people and a lot of expertise to help these animals in the wild. It takes a lot of effort to help these stranded animals and to make sure to tell which one is healthy and which one is sick. But I also think that this provides you with an objective measure that I don't think you can get this quickly and this reliably in any other way. And I think it's a huge step forward. And now we can actually bring this into the field. The equipment we had before it was possible to do it, but it took a lot of time. It took a lot of effort. It took a lot of expertise. It took several weeks to learn how to use it properly. This is very simple. And like you were saying, one of the advantages is with this technology is, in the old technology, you had this flash. It's like a flow cell. So what you have is you pass the air through capillary tubes, and that sets up a pressure resistance or a pressure difference across this flow cell. And especially if animals, sometimes they have a lot of mucus. These animals live in the water, and they pass water droplets through this thing. It changes the calibration. So the animal takes a couple of breaths, the calibration has changed. So you never know exactly where the calibration changes, in which breath, before and after. So it makes it really difficult to be as precise. While this technology, you have these flow tubes, the water droplets pass straight through. and we don't have this change in calibration before and after we do a measurement. So we have much more accurate measurements, and we can trust that the measurements are reliable throughout the measurement period.
Yeah, absolutely. Well, what have been some key findings with your research?
At the moment, I'm surprised how many animals are actually sick. We knew that there's a high prevalence of stranded animals that are sick. This is something that we find there is a huge number of animals with respiratory disease. As I mentioned earlier, some of these flow rates, when these animals are breathing really hard, they can generate really, really high respiratory flows. So, and this has been the challenge. The breath is, in human pulmonary function testing, there's something called FEV1. So we're looking at the respiratory obstruction, and you're looking how much air can you exhale in 1 second. The problem in a dolphin, the entire breath is done in a second. So we need to
Yeah.
adjust things, which makes it, and this is why having this expertise. So we talk to pulmonologists, we work with pulmonologists both in Spain and in other countries. We work with experts at NDD. What do you think we can do? So if we can share this knowledge that we have of these animals and the knowledge that is in human pulmonary function testing, we can make some adjustment to what we can do and how we can do measurements. We have just been talking about, usually what we do is we do measurements when the animals are sitting still. So the animal is sitting still and they're not swimming, and we're wondering if they actually couple breathing to when they're moving their body. So we're thinking about ways of potentially how can we do the lung function testing when the animal is actually swimming, which I can't run around
Right.
in a boat or something, but there are potential ways of doing it to see if there's some coupling in how they're actually doing their how they're actually breathing when they're swimming. And in the past, we've been using this technology to create Fitbits for animals, basically a Fitbit for dolphins. So we're putting these instruments on the dolphin, and the dolphin is swimming around, and we're measuring their activity. And in your phone, you have this, you're taking 5,000 steps today, and you burn this many calories. What if we can do the same thing for these animals in the wild? So we've been using the older technology to do this, and this is something we want to use, this newer, more precise technology that the TrueFlow sensor is giving us, to be able to measure energetics in these animals, to combine lung function with gas analysis. So this is something that we're hopefully going to work on in the future.
Yeah, excellent. And then how do you see this research influencing conservation efforts?
Like I mentioned before, I surprised by the prevalence and the amount of animals with apparent respiratory disease. So I think that if we've been doing this not with this newer spirometer, but with the older one in the field, we've been doing that for over 10 years, and we saw a huge change in the prevalence of respiratory disease after COVID. If we can follow these different populations, follow them through time, and seeing are there changes that are related to pollution, to disturbance in the sea. Maybe there's more boat traffic, maybe there's more fishing, maybe there's in one area there's pollution, or there's been an oil spill. We can relate these effects to respiratory health in these animals. So we can start to look at the effect of human impacts on the environment. So these animals can be really good sentinel species for environmental health, which translate to human health, because if the environment is not healthy, that is eventually going to affect us either directly or indirectly.
Yeah, absolutely. Well, that is the last question that we had. I just want to thank you again for hopping on and answering these questions about this exciting research. It's always fun to get to see this technology applied in different and unique ways. And so we really do appreciate your time joining us this morning.
Wonderful. Thank you.
All right, another huge thank you to Dr. Fahlman for joining us for that interview. Just so excited to hear about how that research is getting used and applied to help these dolphins and ultimately help people in this who share the same world. All right, so to wrap up, the recorded webinar from today will be available on our website underneath the Educational Webinars tab at nddmed.com. Stay tuned for upcoming webinars by following us on social media at NDD Medical. We have some more exciting Beyond the Boundaries, our TrueFlow Technology series. We're going to have some, our month-to-month live trainings that you're used to. And then we'll also be having some special guests for some other more technical webinars this year as well. For updates on this exciting research, publications, and projects, be sure to follow the partners that support Dr. Fahlman, Dolphin Quest, the Global Diving Research, ONR, and of course the Oceanogràfic Foundation. And again, another huge thank you to Dr. Andreas for joining us today. If you have any questions, please reach out to me. My name is Jamie, and I'm a respiratory therapist, and I serve as our Global Training and Research Director here at NDD. I'm always happy to talk to you about this topic or about any other topics of how our products can come and enhance your patient care. And again, just as a reminder, we love seeing these unique applications for our technology and how it can be used for these research purposes. But again, NDD products are for medical use only in the healthcare setting by clinician. And of course, these examples are exceptions in the research world. Thank you again so much for joining us. We look forward to seeing you again soon. Next Thursday, we'll be doing a live training webinar on the Easy On PC spirometer. So if that applies to you, please join us. If not, stay tuned on our website for more opportunities to join us this year. Have a wonderful rest of your day, and we'll see you soon.